Hey everybody, and welcome to the next video of the course. I should apologize in advance during this video if you hear my son screaming. He has been crying for half an hour because after he went to the bathroom, I put his pants on in the hallway instead of putting his pants back on in the bathroom. So I think we can all understand why he's so upset, and he'll be screaming for another probably 20 or 30 minutes or so about that. It's my mistake, obviously. So anyway, in this video, we're going to continue where we left off last time with for loops. So the main goal of this video is just to get more comfortable with for loops by giving more examples. Now, as you can tell from the last sequence of videos, loops are an incredibly foundational topic in computer science. We are spending 4 entire class days, right? More than a week of the class on loops because they are so important. So you have to get comfortable with them before we move on and do other more sophisticated programs throughout the semester. So anyway, this video is one last chance to sort of get comfortable, get our feet wet with loops as we use them more extensively throughout the rest of the course. And for loops in particular here, our second video on for loops. Before we jump into some more for loops, I want to introduce you to a different kind of variable that we haven't seen yet, called a Boolean variable. Let's just recall that we've already seen a couple of kinds of variables, numeric and string. So a numeric variable, as we know, can take on a numeric value like 5 or 3.14. A string variable can take on a value of an English sentence or phrase, like a name, something like that. Okay, a Boolean variable can take on only one of 2 values. A Boolean variable is either true, with a capital T here, or false, with a capital F. Okay? So numeric variables can in principle take on infinitely many values, right? That x could be 5, 6, 7, 8, so on. A string variable could also, in principle, take on an infinite number of values. There are like infinitely many English sentences you could make. Boolean variables are the opposite extreme. Only 2 values, true or false. The reason I'm showing you this now is because they work nicely with loops if you're trying to detect whether or not something is true or false. So you can create a variable that will record for you if something is true or something is false, as we will see in the subsequent examples. Okay, so let's move on to our for loop example 6. We did examples 1 through 5 in the previous video. This example is going to rewrite the prime number checker from a while loop video, now using a for loop. Okay, so we've already done this using a while loop, but now let's use a for loop. And as you'll see, I think for loops are more natural for the kind of iteration we're going to do here. And just recall the algorithm from the while loop video. If you have a number, say n, and you want to check if it's prime or not, what you can do is just start with 2 and see if 2 is a divisor of n. And if it is, then the number's not prime, so you just break out of the loop and record it wasn't prime. If 2 is not a divisor of n, then you just move on to 3 and do the same thing. Check if 3 is a divisor, check if 4 is a divisor, and so on. If you ever get a divisor, you know the number's not prime, because prime numbers don't have divisors, or they have only trivial divisors, if you like, right? Only 1 and the number n itself. So anyway, if you ever get a divisor hit, the number is not prime. But if you make it through all those possible divisors and never get a hit, then the number must be prime. Okay, so anyway, all that to say, the statement n is prime, that's either true or false. So it's natural to have a variable to record either truth or falsity for that kind of statement. So here's a program that will do that for you. So let's grab n from the user. Oops, I'm sorry. It should be input, not intput, but whatever. Int input, give me a number that grabs from the user. Okay, so initially, I'm going to guess that this number n is prime. So I've created here a Boolean variable that I've called prime, and I've initialized its value to true. So initially, I'm going to guess that n is prime. And now, what am I going to do? Same thing as with the while loop, but the for loop syntax is just a little easier to read. So for possible divisor in this range. So I'm going to start at 2 and then end 1 before n. If n divided by that possible divisor has remainder 0, So in other words, if this possible divisor actually is a divisor, then what do we know? We know that n is not prime, so I set prime equal to false, and then if I ever get a divisor hit, I can break out of the loop. There's no reason to keep the loop running, This loop only exists to just check possible divisors up through n minus 1, stopping just before n. Okay, so the way this works is possible divisor starts with a value of 2. So we check and see if 2 is a divisor or not, see if n is a multiple of 2. If 2 gives us a hit, the number is not prime, set prime equal to false, breakout, and so on. Okay, so suppose we make it through this loop and we never once got a divisor hit. So 2 wasn't a divisor, 3 wasn't a divisor, and so on. Well then, when this loop is done running, so when the cursor is here at this if-else, prime would be true still, right? If we never got a divisor hit, then we never changed the value of that prime variable. So the number is indeed prime. So we would just have a little if-else here, right? If prime is still true, as it was up here, if prime is still true, that must mean the number is prime. Otherwise, we know the number is not prime. Okay? So the number is not prime precisely if we ever got a divisor. So anyway, we already did this with the while loop, but here's a for loop structure that would do it for you, and I think the syntax is more natural here using a Boolean variable. Okay, let's move on to our next example, example 7. So let's say you've gotten already a list of exam scores. I'm going to call it exam scores. If you've gotten this from the user, let's write a program that will see if we ever got 100 on an exam. Right? That's really good, right? We like seeing hundreds on exams. If that is the case, if the user ever got a 100, we can congratulate them. Like, hey, nice job, bro. Okay, so the same kind of Boolean variable will determine this for you, because the statement, you got 100 on some exam, right? You had 100 sometime. That's either true or false. So let's just create a variable that will record that for us. So initially, I'm going to assume this person doesn't have any hundreds, and then I'm going to go looking for them. So this for loop, again, for loops nicely iterate over lists. That's one of the nice things about them, can traverse through a list without having to worry about positions. You don't have to worry about position 0, position 1, so on. So score here, that variable just becomes the first score in the list, then the second score, the third score, and so on. So anyway, as I move through the exam scores list, if what I'm currently looking at, if that equals 100, then this statement is true. I found 100, so I'm going to set that equal to true. And then if all I'm trying to do is see if somebody got 100 or not, as soon as I found a 100, I can break out of the loop, make the loop stop running, because I found what I was looking for. So just like with the prime number checker, if I make it through this loop and I never found 100, if I never found 100, this variable here never changed its value from false to then true. Okay? So again, when I make it through this loop, the value of this variable here, found 100, the value of that variable determines whether or not I got at least one 100 or not. Okay, so if found 100 is true, you tell them, hey, nice job. If found 100 is false, if it's still false, right? You never got 100, oh no, you might fail the course, right? Anyway, so there's another example of a for loop that can detect something for you in conjunction with a Boolean variable, right? This Boolean variable here exists only to record whether or not you found what you were looking for. Okay, so now let's write a program that actually, again, does what we've done previously with or sort of done what we've done previously in the while loop video. Let's calculate an average of a bunch of homework scores, but let's do something like what we're doing in here. So for you guys' daily quizzes, for example, some scores are dropped. So let's calculate an average, but let's drop some low scores, okay? So what's a good way to do this? It's important sometimes, or I guess all the time, once you start writing longer and more sophisticated programs, to talk out what you're going to do, right? Get a plan going, So write out the steps it's going to take to do this task. And the first step is to get the scores from the user, I think. And we're going to put them in a list. We know how to do that. We should then sort the scores from smallest to largest, if we can. And why is that a good idea? That's a good idea because then the two smallest scores, we know where they are, they're at the beginning of the list. We have a delete command, right? So we can then use that to delete those two scores from the front, and then we can calculate an average as we already know how to do. So if you look at this plan, I think the sticking point is this: sorting from smallest to largest. If you think about it, that's actually kind of a hard task, If the user is entering their scores in a jumble, so they do like a 10, 8, 7, 10, 9, 10, 3, 5, whatever, right? It can be hard to put that list in order, or it can be hard for you to teach a computer to do that. Now, for the rest of the course, you can just plug into this built-in function called sort that will sort the numbers from smallest to biggest. So you just do mylist.sort. That's just a single command in the code that will sort things from smallest to biggest. If you want from biggest to smallest, for whatever reason, you do a command like this. This is a single line of code. Mylist.sort, and then inside the parentheses, right, they're no longer empty. You write reverse equals true. That's sorting from biggest to smallest instead. Okay, so I have this program implemented here. Let me just show you the code. Okay, so homework scores, that list is initially empty because they haven't given us anything yet. We grab a first score from them, and the text here is large, but let me just show you the English message here. Enter your scores one at a time, enter a negative number when done. Okay, so that's the standard sort of way we've had people hand us scores. A negative number is what will break out of the entry loop here. Okay, so as long as they're handing us a score that's positive or 0, I'm going to throw that score into the list and then let them enter another score. Okay, so we've done that before. So now we can just do a command like this. That's its own line of code. Homework scores.sort. Now the scores are sorted from smallest to biggest. So line 15, when you delete the score at position 0, that's the first score, right? The smallest score has been deleted. Now in line 16, you might think we want to delete like the next score like that. Like you delete score 0 and then delete score 1. However, if you have deleted score 0, that is literally gone from the list, right? So if your smallest score is a 3, the list starts with a 3. When you do this line of code here, that 3 is gone. So if the next smallest score is a 4, the 4 is now up front. The 4 now starts the list. So anyway, you got to delete the thing up front. Then the second smallest actually becomes the thing up front and delete that. And then here now, this calculating of an average here, we've already done that. Okay, so let's run that and see how this goes. So just to make sure it works properly, I'm going to enter things I know. So okay, a 10, 10, 10. So far my average is a 10. Now let me put in a couple of low scores, like maybe a 3 and a 7. Okay, and then I'll terminate this. I'll enter a negative 5. It prints an average of 10. Okay, so notice it didn't take an average of 10, 10, 10, 3, 7, right? That average will be lower. What it did was it got rid of the 3 and it got rid of the 7 after doing the sort and then doing these two delete commands. So it knows that the average with the two lowest scores dropped is a 10, right? Before leaving this example, let me point out that suppose you wanted to drop more than 2 scores, right? Suppose you wanted to drop 8 scores. I suppose you could just do this. You could like copy and paste this a bunch of times. This starts to get ridiculous though, right? Keep copying and pasting this. I mean, what if you wanted to drop 1,000,000 scores or whatever, right? That's not realistic for us, but you can imagine code where you want to drop, say, 500 things, 1,000 things or something from a data set. You don't want to write this command 1,000 times. So instead what you can do is something like this. One of the nice things about for loops is that you can control how many times they run. So suppose you want to delete 5 scores, say. Consider a for loop like this. For k in range 5. By construction of for loops, this loop will run 5 times. Okay, that's one of the nice things about for loops. You can set them up so that this number right here is just the number of times they run. So k will start at 0, become 1, 2, 3, 4, right? 5 values for k. And every time k changes value, or every time the loop runs, what happens? You delete what you see at the beginning of that list. So the first time you run through this list, you're going to delete the smallest score. The next time you run through the loop, what are you going to do? You're going to delete the smallest score now, which is the second smallest score, and so on. So anyway, you can do something like this to save yourself. Like if you ever just have to write the same line, literally the same line of code a bunch of times, you can just write it once, put it inside of a for loop that runs as many times as you want it to run. So there's another application of for loops. Okay, the last thing I'll show you here, the last example, is a nice counting loop. So for loops, as we've mentioned before, are nice for counting. So here's just a toy example. Suppose you want to count the number of times the word the appears in a string. How might that go? It looks a bit complicated, but let me just walk you through it. Okay, so consider this phrase right here. The cat is in there in the house the. Okay, so in practice, nobody would really end a sentence like that, but whatever, you know. So counting the number of occurrences of the word the is a bit more complicated than it might appear, because really what you're usually counting is space, the space. Right? That's what you're looking for. You're looking for space, the space, usually. So you don't just want to look for the letters T-H-E in that order, because consider the word there. Right? You wouldn't want to say, oh, the word the appears, right? Because there's a T-H-E in that order, you know. So you got to be a little careful about what you're counting. As I've put in quotes here, you're not actually looking for those three letters in order. You're looking for, in general, space, T-H-E space, with two exceptions. What if the word the starts at the beginning of the phrase? Then you're not looking for space, T-H-E space. You're looking for T-H-E space. Okay, because most phrases don't start with a space. What if this person is speaking gibberish and they end the phrase with a T-H-E? Then you're looking for space T-H-E, right? You're not looking for space T-H-E space. So you got to cover all your bases is all I'm saying. Usually you're looking for space T-H-E space, but it could be the case that the sentence starts with a T-H-E space. Could be the case the sentence ends with a space T-H-E. Okay, so the way this works is you grab the phrase from them, you set up a count variable that will just count the number of T-H-Es you see, and now I'm going to create a variable k that's going to just walk through the string, and I'm going to just record what I'm seeing as I'm walking. So when k is 0, I'm at the beginning of the string, right? And then notice it says here, if phrase k and then colon k plus 4 equals T-H-E space or capital T-H-E space, right? Then I'm going to up the count because I found a T-H-E space. Recall this notation here. What does this mean? It means I'm looking at the substring that starts at position k and then looks at k plus 1, k plus 2, k plus 3. So there are 4 letters, right, or 4 characters. K, k plus 1, k plus 2, k plus 3, but not k plus 4. This is not inclusive on the right. Right? That's obnoxious. We've all been annoyed by that, but it is what it is. You know, I can't do anything about it. Anyway, so if k is 0, I'm saying if phrase 0, and then this would be a 4 right here, right? So 0, 1, 2, 3. So all this is doing, right, is if the phrase starts with a the, count it, you know. Otherwise, if k equals, now what's happening here? I'm going all the way to the end of the string, length phrase minus 4. And I don't want to look literally at the last character, you know, because the last character, there's not enough space there to get a space T-H-E. So I back my way up by 4 slots, and I again just check. Do I see a space T-H-E, or do I see a space capital T-H-E? And if I do, up the count by 1. So anyway, this first if just detects if there's a the at the front. This else if detects if there's a the at the end. Otherwise, right, this catch-all bucket at the end, well, what if you're not at the start? What if you're not at the end? You must be in the middle somewhere. And in the middle is where you're looking for the space T-H-E. Okay, so notice now, right, k colon k plus 5. Okay, so how many things are you looking at? You're looking at k, k plus 1, 2, 3, 4. 5 characters you're looking at there. And you're going to ask, is what I see space T-H-E space? Or with a capital T? Space, capital T-H-E, space. And if I do, I up the count. Okay, so the reason I show you this example, this is sort of confusing to look at, right? But again, you can use a for loop to count all sorts of things. In particular, you can use it to count the number of times a word appears. Now, we have used for loops to count the number of times a letter appears inside of a string. We did that last time. Again, searching for words inside of sentences is a bit more complicated because you have to account for the spaces, right? Space like that. Okay, so that's all the examples of this video. Hopefully these further examples have gotten you more comfortable with for loops.